Hello. So these two questions I am going to discuss. Both are 2 marker question. 2 marks may generally they ask by the CBSE. So look at this question is there. If sin inverse x plus sin inverse y is equal to 2 pi by 3, we have to find the value of cos inverse x plus cos inverse y. See. So we have sin inverse x plus sin inverse y is equal to 2 pi by 3. We want to find the value of cos inverse x plus cos inverse y. So this is already we know that sin inverse x plus cos inverse x is equal to what? That is pi by 2. So with the help of this one, you can write the value of sin inverse x in terms of cos inverse. So this sin inverse x can be written as this is pi by 2 minus cos inverse x. Similarly, sin inverse y you can write down from here pi by 2 minus cos inverse y is equal to 2 pi by 3. So pi by 2 plus pi by 2 means that is pi. You can transpose this 2 pi by 3 on this side. Minus 2 pi by 3 is equal to cos inverse x plus cos inverse y. You can transpose on the right hand side. Transpose this 2 pi on this side. Pi by 2 is pi. So therefore you can say cos inverse x plus cos inverse phi is equal to pi minus 2 pi by 3 means that is pi by 3. So this is the value of cos inverse x plus cos inverse phi. Similarly, this is one more question is there in 2 mark. Express sin inverse this where x is greater than equal to minus pi by 4 but less than pi by 4 in the simplest form. So this is given. We are given sin inverse. We want to write this is in the simplest form. So what we will do, this root 2 you can write down with the sin x and cos x separately. So what we will get, this is sin inverse 1 over root 2 sin x plus 1 over root 2 cos x. And this can be written as in terms of sin because the value of cos pi by 4 is 1 over root 2. Value of sin pi by 4 is also 1 over root 2. So this can be written as sin inverse. This is cos pi by 4 because cos 45 is equal to 1 over root 2 into sin x plus sin pi by 4 into cos x. And this is sin A cos B plus cos A sin B. So this can be written as sin inverse sin A plus B. Sin pi by 4 plus x, and this is equal to pi by 4 plus x is your answer. Have a look. Okay, now one more question. Here is the proof that tan inverse 6x minus tan x cube 8x cube over 1 minus 12x square minus tan inverse 4x over 1 minus 4x square is equal to tan inverse 2x. We are supposed to prove this is equal to this one. See, if you are going to apply here is tan inverse x minus tan inverse y and trying to get this tan inverse 2x is quite complicated. So this is actually is a tricky question. You can apply the trick is there. See, look at it now. This left hand side I am taking and we will try to get this right hand side. The trick is here, this tan inverse, this one can be written as this 3x, you can write down 3 into 2x minus this 8x cube can be written as 2x whole cube over 1 minus this 12 can be written as 3 into, because there is a formula is there only, that is can be written as 3 into 2x whole square because 4x square into 3 this one. Similarly, this can be written as tan inverse 2 into 2x over 1 minus 2x square. This is. The trick is here, you are supposed to break this one in the 3 into 2x minus 2x whole cube over this one and minus this. Now, you can assume, just let 2x is equal to tan theta. Just you can assume this 2x is equal to tan theta. So what you will get is here only this is your tan inverse 3 tan theta minus this is tan q theta over 1 minus 3 tan square theta. Similarly, here is tan inverse 2x is already we assume tan theta over 1 minus tan square theta. This is, but this 3 tan theta minus tan q theta over 1 minus 3 tan square theta is equal to tan theta. This is already we know that. This is your tan 3 theta minus, and this 2 tan theta over 1 minus tan square theta is equal to tan 2 theta. So tan inverse, this is your tan 2 theta. So tan inverse tan x can be written as x. So this is 3 theta minus, similarly tan inverse tan x is equal to x, so that is 2 theta. So 3 theta minus 2 theta is equal to theta. See, this is already we assumed from here. So 2x is equal to tan inverse tan theta is already we assumed here. So from here you can write down theta is equal to, therefore theta is equal to tan inverse 2x. So what is this? So this is equal to tan inverse 2x, which we want to prove. So if you are going to apply this trick is there, this is tricky question, you can say that. Tricky question is there. If you are going to apply this trick is there, it's quite easy. But if you are going to expand like tan inverse x minus tan inverse y is complicated, lengthy, the calculations will be there. So you can write down this is in the form of like 3 into, so you will get tan 3 theta and here is tan 2 theta, then direct you can find the value of theta which you require equal to tan inverse 2x. Have a look. Okay, now question is solve for x tan inverse x whole square plus cot inverse x whole square is equal to 5 pi square over 8. See, in this question we are supposed to find out the value of x. We have to find out the value of x is here only. So in this particular question there is a one trick is there which we are supposed to apply is here. If we talk about, let's suppose this is your a and this is b. So this is a square plus b square. So a square plus b square we can write down in the form of a plus b whole square minus 2ab, because if you are going to solve it, a square plus b square plus 2ab and minus 2ab cancel, so left side is equal to RHS, LHS is equal to RHS. So same we are going to apply. So in place of tan inverse x whole square plus this one we can write down tan inverse x plus cot inverse x whole square minus 2 tan inverse x into cot inverse x is equal to, this is as it is 5 by pi square over 8. Why exactly we are going to apply this one is here, because now in place of this one tan inverse x plus cot inverse x you can write down pi by 2. This is already you know that tan inverse x plus cot inverse x is equal to pi by 2. This is already we know that. So in place of this one we can write down pi by 2 whole square minus 2 tan inverse x. Either you are supposed to change the cot inverse x in terms of tan or the tan inverse x in terms of cot, it's up to you only. So I am going to change the cot inverse x from here in terms of tan, pi by 2 minus tan inverse x you can write down. So in place of this one you can write down pi by 2 minus tan inverse x is equal to 5 pi square over 8. So this side you will pi by 2 whole square means pi square over 4 minus 2, you can multiply here 2 into pi by 2 into tan inverse x minus minus plus plus 2 into tan inverse x whole square is equal to 5 pi square over 8. This is the concept is here. This is the very important point is here only. Now see, this 2 cancel. This can be written as, in the simplest form I am going to write 2 tan inverse x whole square. This is minus pi tan inverse x plus pi square by 4 minus 5 pi r square over 8 is equal to 0. Actually, I want to write this equation in the form of quadratic equation. So that's why I am going to transpose this on the left hand side is here. So what you will get now? 2 tan inverse x whole square minus pi tan inverse x plus, you can here is 2 pi square minus, so you will get minus 3 pi square over 8 is equal to 0. You will solve this one. 8 LCM, 2 pi square minus 5, so minus 3 pi square over 8 is equal to 0. 2, you can remove this 8, so you will get 16 tan inverse x whole square minus 8 pi tan inverse x minus 3 pi square is equal to 0. So finally you are getting this is, if we assume this tan inverse x is equal to a or any other term, so you will get the quadratic equation. Then you can solve this quadratic equation. So look at here now. I am going to rub. So finally this is your equation. So you can assume that this is tan inverse x. You can assume that tan inverse x is equal to a. For the own convenience, I am going to assume this tan inverse x is equal to a. So you will get the equation 16a square minus 8 pi a minus 3 pi square is equal to 0. See, so this is the equation like a quadratic equation where the x we are treating as a variable and this 8 pi and 3 pi and this 16 is the constant. See, splitting the middle term, 16 into 3 pi, 4 into 4 into 3 into pi into a. We are taking this a square a into this one. So you will get what? 12 and 4. So this is, you can say 12 pi a into 4 pi a is equal to product of these two, but 12 minus 4 is 8. So this can be written as 16a square. Just splitting the middle term, I am going to apply here, plus 4 pi a minus 3 pi square is equal to 0. This is your quadratic equation. I am going to find the factor for this a. A I am treating as a variable. You can take out the common. So here you can take out the 4 common, 4a. This is 4a minus 3 pi. From here you can take out the pi common. So you will get 4a minus 3 pi is equal to 0. So this is 4a minus 3 pi in one bracket and 4a plus pi another bracket equal to 0. So finally we are getting this one. It means now the product of these two is equal to 0. It means either this will be equal to 0 or this one. So you can say either 4a minus 3 pi is equal to 0 or 4a minus plus pi equal to 0. From here, if you are going to find the value of a, that will be equal to 3 pi by 4. And from here, a will be equal to minus pi by 4. See, this 3 pi by 4 we are going to reject, we are going to neglect. Why we are going to neglect? Because in case a is already we assume tan inverse x. So in tan inverse x, x belongs to minus pi by 2 to plus pi by 2. So this is the value of 3 pi by 4 is not going to belongs to this one. So this will be neglect is there only. So what you will get? A is equal to minus pi by 4. That is tan inverse x. The value of this one is tan inverse x is equal to, you can say, is equal to minus pi by 4. And this can be written as x is equal to tan inverse minus pi by 4. This is x is equal to tan inverse. You are getting the value is here. Look at here. So this is the value is going to neglect is here because this is does not belong to this interval. But this x equal to tan inverse minus pi by 4. So it means what we will get? X equal to minus 1 because tan pi by 4 means that is you can say x equal to minus 10 pi by 4 means that is 45, so x is equal to minus 1. So you will get the value of x is equal to minus 1 is there. Have a look. So one more question. Find the number of positive integral solution of the equation. Your equation is given tan inverse x plus cos inverse y over under root 1 minus y square is equal to sin inverse 3 over root 3. Already I have written the solution, so you can save your time. See, now this is the information is given tan inverse x plus cos inverse y over this equal to this one. See, tan inverse x keep as it is, but you can change this cos inverse y over under root 1 minus y square, that is equal to tan inverse 1 over y. Tan inverse 1 over y, you can calculate from here the value of the tan. Similarly, from here sin inverse 3 over root 10 will be equal to tan inverse 3. Now you are supposed to transpose this tan inverse x on the right hand side, so you will get tan inverse 1 over y is equal to tan inverse 3 minus tan inverse x. Here you can apply tan inverse x minus tan inverse y formula. So that is equal to, we know the tan inverse x minus y over 1 plus xy. So that is, we are going to apply tan inverse x minus tan inverse y. So tan inverse 3 minus x over 1 plus 3x. So tan inverse 1 over y is equal to this one. So you can say 1 over y is equal to 3 minus x over 1 plus 3x. Look at here. So therefore y equal to, you will do, so this 1 plus 3x will be numerator and 3 minus x is in denominator. Now here is the important point is here. We want to know the number of positive integral solution of this one. It means x and y are positive. Those, they should be the positive. It means to get the value of y is positive, this your x. See, this denominator 3 minus x cannot be equal to, number one, the 0, first of all, because this cannot be, or forget this one, means it cannot be the negative. It cannot be the negative is here only. See, now you are going to put the value of x is here. You are going to put the value of x is here. This should not come negative because here the positive is there, because they are the positive value. So what value we can put for x here only, so we can get the value of y is positive. X ka what value we can put, so we can get the value of y is positive. So if I am going to put x equal to is 1 is here, 1, then I will get the positive value because 3 minus 1 is 2. And similarly, if we put x equal to 2 is here, x equal to 2 is here, then you will get the positive values there only. If I am going to put x equal to 4, 3 minus 4, that you will get negative. But we want only positive integral solution. So therefore, x will be 1 over 2. And what will be the y? Y is equal to x equal to 1 you are going to put here only. So 1 plus 3, 4 over 2. So that y is 2. You are going to put, now x equal to 2 is here. 6 plus 1, 7 over 3 minus 2 is 1. So x, y is equal to 7. So if x will be equal to 1 and 2 and y will be at 2 and 7 because due to this one only, otherwise value may be different is here. So this is the important point is here only, because this x cannot be more than this 1 and 2 because both should be positive, because if the more than that value we are going to put, you will get the negative value. So x will be equal to 1 2 and y is 2 7. Have a look.